Oh, hello guys. So in this I'm going to teach you DFS. DFS is an important searching algorithm in both graphs and trees. Uh, so using DFS we can implement searching on graphs. Otherwise, implementing searching on graphs would be very hard. So DFS and BFS are the main two algorithms for searching on graphs. Using DFS, we are going depth-wise searching. Okay, I will explain to you what I mean by DFS or depth-wise searching. So in DFS, we start from the first node and we go down till the bottom of the tree. So we first traverse through the entire depth. So I will show you how a flow of DFS happens. So we will start from here, then we will go all the way over here. So we have traversed through one of the branches. You can say branches of the tree, or you can say hand of the tree. We have traversed through one of the branch of the tree and reached at the bottom. So that's what basically DFS do. Like we first uh, try to reach the bottom of every branch, and then we backtrack to over here, go back to over here since we haven't traversed this branch, and since the parents of this branch are already traversed, we don't need to go back to them. So we just need to go back till here, and then we traverse down, and then we go back to here because there are no positions to go back to which and traverse because all the branches in this branch are traverse. So we from here we go back directly to here. Then from here we go down traverse. Then we go back to here. Then from here we go to here. We go to here. So we reach the depth of the tree, and then we go back to here because there is a branch to traverse over here. Then we traverse that branch. So this is basically DFS. This is we are go exploring uh, in depth uh, of a tree or a graph. So now I want to explain to you a problem that we can solve using DFS, and I have implemented the problem using DFS. So we have been given a 2 m into n by a 2D binary grid which represents a map of ones and zeros, where ones represent land and zeros represent water. We have to find the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So a land is a island is a connected piece of land. So this is a land. This is connected to this land, this land, this land. Then this is connected to the land below that, and this land is connected to this land, this land is connected to this land, this land is connected to this land, this land is connected to this land. So this and all the lands in this particular M into N grid form an island. So there is only one island over here. The zeros are water. So there is only one island over here. So we print the output as 1. Now if we go over here, this is a land, this is a land, this is a land, this is a land, and these two are interconnected. This is one island. If you look over to the adjacent, there are no lands present. Okay, there is a land over here, but it's not left, right, or down. This is diagonal, so we don't consider that. We only consider an island to form if the land is uh, at right, or left, or up or down. So these four ones are an island. This one is an island. These two ones are an island. So there are total of three islands present in this M into N grid. So now I will show you the DFS implementation on how we can find the number of islands. So the grid is the the metrics that they have given us. So if we go m into m is equal to grid dot length, it will give us the number of rows present. And n is equal to grid of 0 dot length actually represents the number of columns, because like so we are taking a particular individual uh, the zero the zero sub metrics of the metrics that we are considering and checking how many elements are there. So suppose like 1, 2, 3, 4, 5, there are 5 elements over here. So those 5 elements, the number of elements in that particular submatrix will be also be the number of columns, because like look, these form starting from this is one column, 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 starting from this is one column. So the number of elements in this submatrix is the number of columns as well. So we understood that right now. And now I have defined a variable count to get the number of islands that are present. Now we define a for loop till the number of rows. Then we define another for loop till the number of columns. And if we encounter a cell which is a land, we start the DFS. So we start the DFS from the cell coordinate. So the cell that we are the land that we are encountered is at the ij coordinate. So we start from that, and we pass in the metrics also as a parameter. And now I will show you what happens when we pass in like that. When we pass in like that, we'll first, okay, I will explain to you what this if condition is. First, we initialize the land to 0. Okay, we already encountered the land. We need not encounter it again. And since we encountered it already, we have taken into account, and we don't need to encounter it again. So we are turning that into water. And now I'm checking. Okay, is there any land? Is there any land uh, on top of it? I minus 1 is row minus 1, so it will be checking, we will be checking on top of us. And DFS ij minus 1 is column minus 1, so we'll be checking the left of us. And DFS I plus 1 will be checking the below us, and DFS j plus 1 will be checking the right of us. So, so we are checking all the 4 directions. And if we encounter land in any of the 4 directions, we go to that place as well. We go to that path as well, and change all the ones to zeros. Now, when does this if condition is executed? If I is the current row that we were in. So while we are traversing through the matrix, if I exceeds the number of rows present in the matrix, we have to break up the loop. We have to stop the recursion. We have to backtrack the recursion. Or if j greater than or equal to the number of columns, we have to backtrack the recursion. If I goes below the minimum number of uh, rows present in the matrix, we have to backtrack the recursion. Or if j goes below the number of minimum number of columns present in the matrix, we have to backtrack the recursion. Or if grid of I of j is not a land, if it's not a land, there is no need to consider that particular cell, right? So we are only considering adjoined land. So no need to check that. And since we have encountered a land and we have explored every possibility of it, we will increment the count plus 1 since we have encountered an island. So when we run this code, it will pass, and actually this particular code that I have implemented has a very good time complexity. Look, it beats 100% of all the users in Java. Very good time complexity. And the space complexity is mainly due to language dependency. I don't think I can improve my space complexity anymore than I have improved right now, because it's, let's say, language limitation. So yeah, this is all about DFS, and I hope you have understood. Yeah, thank you.